So hi everyone, my name is Yasmin Hassan and these are my colleagues.
Salma Hassafi,
Mariam Sadiqi.
We are chemical engineering students at the American University of Sharjah, and this is our mass transfer project, Spring 2019, which is on the effect of temperature and time on the rate of absorption of water on a common material. In our case, it's lasagna. So in this lab, we're going to present the experiment, and at the same time, we're going to demonstrate the conclusion and the results. So thank you for watching and hope you enjoy.
The first step was choosing a single lasagna brand so we would be consistent throughout all of the trials and experiment. Then we cut the lasagna rolls so they would fit the beaker, and their weight was roughly around 9 to 10 grams to remain the consistency. The second step in experiment was measuring the mass of each piece before putting it in the water bath.
The third part of the experiment involved the actual placement of the piece into the water bath. This water bath behind me is used for the lower temperatures, so temperatures ranging from 25 to 40 degrees Celsius. At each temperature, we took multiple trials. Each trial removed a piece at a certain amount of time. For example, if we had 6 trials in a single temperature of known mass prior to the experiment, they would be withdrawn at certain time intervals, the first one being 3 minutes, the second 5 minutes, after that 8 minutes, and so on. Once the time trial had finished for a certain trial, the piece would be removed. In cases of high temperatures, the piece would first have to be strained over a beaker so that excess water may be removed. Afterwards, piece would be placed on the scale and the new value would be recorded.
So as you've seen in the water bath, we used it for temperatures between 25 and 40. Now we're going to use this temperature heater for temperatures above 40, but we're moved really slowly because it can only hold one beaker at a time.
Having collected the data and measuring the mass before and after each trial for each lasagna sheet, we calculated the percentage difference in mass. Percentage difference in mass is calculated by subtracting the initial mass from the final mass and dividing it by the average of the two masses. After finding the percentage difference in mass, we plotted it against two variables that we were measuring, time and temperature. Let's begin with describing the percentage difference in mass versus temperature. As is shown from the graph, increase in temperature causes an increase in percentage difference mass, clearly proving our hypothesis that at higher temperatures, the rate of diffusion of water into the lasagna sheet is higher. And a noticeable trend over here is that at temperatures prior to 55 degrees, the increase in mass is quite small relative to temperatures above than 55 degrees, where the increase in mass and the slope increases. Moving on to comparing percentage difference in mass versus time. Similar to temperature, increase in the time of lasagna sheet in the water bath causes a higher difference in mass. Generally, at lower temperatures, the difference in mass, even after 20 minutes, was much smaller than a difference in mass at 80 degrees Celsius. Moving on to discussing the errors in the percentage difference in mass versus temperature graph. It is clear that at 55 degrees Celsius approximately, there is an unusual dip in almost all the times. Moreover, you can see that the blue and green lines that represent 18 and 20 minutes go down below the yellow line that represents 16 minutes. Theoretically, at a higher time, the measurement of the mass should be higher. However, it dips over here. The reason for these errors could be because of the incorrect measurement of mass when the lasagna sheet was taken out. Additionally, when we were using the high temperature water heater, the temperature was very fluctuating and it was very difficult to maintain the temperature that we required. Moving on to talking about the errors in percentage difference in mass versus time. At the high two temperatures, representing by 60 and 79 degrees Celsius, there is an unusual dip at 16 minutes as well as at 18 minutes. Again, the reason of these could again relate back to an incorrect measurement of mass. It might also be because we did not allow for the water to drip out in the strainer correctly, and same for all the different times.
After discussing the results and data, we have concluded that the rate of absorption of water into the lasagna sheet is directly proportional to the temperature and time. Thank you for watching.